right? So make sure you work towards being a hardworking student. And I know you all have someone in your life that you look at, it's like, yeah, hardworking person, right? So try to be that as well. Okay, enough of ranting, right? Let's focus on this. Page 49, type 0. Why do I call this type 0? Because quite often the points are just given to you. Like you just have to plug it in and go. You will see as we move forward, the other types, you have to come up with the points. And I'll show you how to do that. Okay. So we came up with our equation. We found the y-intercept. The stunt ends when the plane reaches the initial height. So we figured that out, but I stopped there. So let's do this. Can we do this together again? I just want to make sure you have the same. And I don't like stopping a lesson halfway, but it is what it is. So how do we do this again? Stat edit. Go to the top, hit clear enter. Top, clear enter. And then just type everything in. You're much faster at typing than me. I know that. So I'm just double checking, right? Double check your points. It takes maybe half a minute max. I would say 10 seconds, but hey, there we go. So I make sure everything is good. Hey, did I do a regression today already? At one point I did, right? So why don't I save myself some time? I'm gonna go second, quit. I'm gonna go up. Oh, there it is. I did that already. Why would I do all that madness again? So let's say you ever forget your study sheet isn't really good. If you just scroll up enough, you might find it. You might find this already done. So you just go enter, enter one more time, boom, there's your equation. Without having to do all those buttons, right? So if you do this enough, it's gonna be there somewhere in your history. So that's another way out. So you gotta be, troubleshoot and see if you do this right. Okay, we have the equation. Let's hit graph. And I like that it's not gonna be there because that forces us to see how do we fix this, because that's gonna happen. Zoom stat, remember? When you put stuff into your L1 and L2, there are points somewhere plotted on your graph. So I'm gonna try that. I'm gonna go zoom stat. I should maybe show you what happens when plot 1 isn't on. Watch. You don't have to do this, but I'm going to turn off plot 1 because you didn't use it for a while. You're doing other units. And you're like, okay, I remember Mr. Erickson saying zoom stat. Let's see. Huh? It's not working, right? See that? I'm going to try it again. It's not working. It means it's because plot 1 is not turned on. Those dots that you're trying to plot, they're not there. Now I'm going to try it again. Zoom stat. There it is. Let's make a little note here. I will make a note here. Turn on plot 1, then zoom stat. Okay? Adjust window after. Adjust window afterwards. Because some students think this is going to be like this silver bullet that's just going to solve all of my problems. It's not. It's just going to give you a reference. Okay? So what do I mean by adjust window? You go to your window, the x-min and the y-min, you want it to be somewhat in the negatives. Okay? So y-min, I'm going to go -5. Sorry, x-min I meant to say. X-min, a bit negative. Go to your y-min. You also want negative. -10, -5. It doesn't matter. Just make it so that you can see your axes. Okay? Now I'm going to hit graph again. So the mins are in the negatives. Hit graph. It's pretty good, except for I would like to see my y-intercept. So I'm going to go back to my window. Increase y max. My y-intercept is 1080, right? I know that. So I'm going to go 1200 or something like that, 1500, something that's a little bit past it, and there we go. Now you see your y-intercept, and I would like to also see that I'm coming back to that height. That's somewhere over here. That means I have to increase my x max here. So we're gonna go window. I'm gonna go 50. I don't know. Doesn't matter. Really doesn't matter. It's a little overkill, but I see everything. Okay. We ended with how long was this? How long did the stunt last? Like that's where we ended up with here. Well, the stunt will end when the plane reaches 1080 again. This is your initial height. So we went y equals y2 is 1080. Then we hit graph. There we go. So the stunt starts here at 1080 and then it ends here. So the time that went by, right? The horizontal? The curve? Okay. 1 second. So can you find that intersect right there? I'll be right with you. What your problem is. So just let me know. Okay? Just let me know. All right. Let's find that. Second trace 5. Oh, I'm not on the, my cursor is not even on the screen. So I'm gonna go left, and there you go. It shows up there. So enter, enter, enter. That's 19.60 technically. X is 19.60 seconds. I don't need to subtract anything because I started at time 0. It's almost like saying this minus the first time, but the first time it happens, it's time 0. It's when the stunt is starting. So this is the time. If that line had been anywhere down here, you would have to subtract to figure out how long it took to stay below a certain height. Okay, so this is where it ends. All right, let's keep going. D, what is the plane's lowest height? I think you should be able to answer that one. Happens at the vertex. So let's go ahead and find the vertex. This is a second trace min scenario. We're going to find the lowest point, right? It's a dip, not a max. Okay, so you have to be careful. So let's go ahead and find it. Second trace minimum. And you have to go to the left of the minimum, right? Somewhere to the left. Enter. And then somewhere to the right. Enter. And enter one more time. That is 9.79. So that's 80. And that's 179.625, which is 6.3. So that's the vertex, right? Lowest height, lowest altitude, or does it say height? It says height, so we'll just stick with that. Is 179.63 feet. That's how low it goes. It's going to be above the ground. There. E, graph this scenario. So when you graph this, you want to put yourself in a word problem scenario. Okay, guys? I'm going to give you some hints. Like, where does it stop somewhere? Does it hit the ground, right? If it's a projectile. In this case, we know that it starts at time 0 and it ends when it comes back to the original height. Okay, so let's do what's most important to get started. So we're going to go arrowheads on the axes. We're going to call this height in feet. And we're going to put time in seconds. Perfect. We're going to put the equation here somewhere. That is, I wouldn't put it like inside the grid just in case you need that space. And now you need to come up with a scale that works. And I wish I could zoom into the graph, but I want you to see the points because I'm going to use the points that I've come up with. I have my y-intercept is 1,080, so I need to go up to 1,080 for sure. And the stunt lasts, like time, if you look at time, it lasts 1960, right? So I need to account for that. Let's see what works here. I'm going to try things here. 200, 400, 600, 800, 1,000, 1,200. So I make sure that I make those markings very clear. I don't want you to just write numbers anywhere because I need to know what the scale is. So 200, if I go up by 200s, that will allow me to fit in the maximum height there. So we're good to go. And then down here, I'm going to try 5, 10, 15, 20. I think that's a pretty good scale. So I'm going to go up by 5s here. And it is consistent because I'm using every fourth box, right? You can choose to go up with a different scale. That's fine, as long as it's consistent, as long as the spacing is consistent, we're good to go. Let's plot this. 1,080 along the y-axis. This would be 1,100 right here. So 1,080 is just below that, so somewhere there. I'm going to use a ruler to help me out with this because I come back to that height somewhere. Right? I'm going to come back to that. That's at 1960. I found that time, 1960. So I'm going to make that there. 1960 is very close to 20. So right about there. That's where the stunt ends. So in this case, you don't have any x-intercepts, so these act as if they're your x-intercepts, right? Almost like your 2 points on either leg. And then the vertex is 9.80, 179.63. 9.8 is very close to 10. This would be 100. This would be 150. 179 would be right about there. Don't make the dot too big. And then I use my vertex to help me out. So I go a little bit sideways and then I curve up. And the stunt ends there, so stop there. Back to the vertex. And sometimes you want to go light and then just make the curve look like that. It ends there, right? I'm just going to make a note. Ends here. Sure, the plane keeps flying, but this model here, this parabola, is only specific to starting at 1,080, doing that dip, coming back up to the initial height. That's it. So that's what this is modeling, just that little stunt. Okay? That's it for the graph. So it's not always pointing down. Most of them are pointing down, but sometimes it will not. Okay? Okay. E. No, we did E already. Why did I? I'm just going to call this E here. And this would be F. Fun stuff, the domain and range. I'm going to ask you, if you already did this for homework, obviously you probably know the answer. But if you didn't, this is your chance. What would you write down for your domain and range? It shouldn't take you longer with the information I already gave you. It shouldn't take you longer than 2 minutes to come up with that. It would probably, I would say, half a minute for each. What would you write down? Go ahead and just write it down. Take the risk. And then if you get it wrong, that's not a big deal. We'll correct it. For the domain, we start at time 0, right? and we make it all the way to 1960. That is your domain. That's for time. Okay, that's your time if you want to write that down. And for range, it's what's acceptable for my y values. So the lowest y value I ever am allowed to have is 179.63 and as high as 1080. Nothing below, nothing above. That's all you're allowed in this case. So your domain and range should jive with your graph, by the way, right? It should. G. How long was the plane at or above 800 feet? This one is actually very tricky. I'm not gonna lie, okay? Tricky. We're gonna go ahead and do the what most of you probably attempted right away. Y2 is equal to 800, and then we're gonna go second, trace, intersect. Let's go and find those 2 points. So time 1. Okay. Time 1. Actually, hold on. I have to do this again if I want to. I'm gonna go with the first time and round it to 4 decimals. That's 1.6653 time 2, second trace 5. Let's go ahead and find it. Enter, enter, enter. That's 179346. Now, this is where it gets, I wish I would have had a bit more space here. Okay. When you go delta t, because I don't know if that's what you were thinking you should have done here, but I would say for sure you should have thought, hey, I have to subtract these two. So we're gonna go 17.9 ... minus 1.6 ... delta t gives you sorry, I have to do this because I'm keyless right now. That'd be 16.2693 seconds. But what did I find when I subtracted this? I'm going to let you write it down first, then I'm going to point that out. When you subtract, okay, like these 2 times, follow me here on this graph real quick here. 800 is right there. These are the 2 points you found. I think it's okay to have the 800 line here. This is the y equals 800 line. Okay. When you subtract, you're finding the time within these 2 times you found. Okay. So what happened from here to here? Where were you? You were below 800 at that point. So what you found is time below 800, at or below 800. So this is time at or below 800 feet. I'm going to zoom into just that corner. You need what? What does the question ask for? At or above. That's what the question is asking. Time above is going to be the total flying time of the stunt minus the 16.2693. Okay. And that is 3.3 0.33 seconds. I kind of ran out of runway here, speaking of planes. Okay. I'm going to try to give you a little. It's going to be small. Sorry, guys, but that's all I've got. Okay. It's going to be right here somewhere if you find space elsewhere. If this is your graph, right, and this is the 800 line, I'm going to use two different highlighters. When you subtract it, like this time, actually refer to the dip. The time we're after is figuring out the orange parts. That's the best I can do with that little space there. This is gonna be very rare, but that I ask for this, like for you to do that, but it is possible that I ask for something like that. So ultimately, you spent 3.33 seconds. Let me show you the graph here. Can we do it on the graph? I think it's all right. Like this orange is the time spent here and here. Okay. And when you subtracted those 2 times you found, because that was absolutely critical to find the 2 times, you find out what happened between those. And that would be at or below. Okay. I don't really want you to do this on like a, oh, I wouldn't actually complain because you show understanding. Okay. But so what I did is I did subtract to find, hey, how much time was spent here? And then I took that away from the total flying time of the stunt to give me the orange pieces. Okay. All right. What time is it? 11:30. I assigned 49 to 50. And I would still hold to that you should have tried 49 and 50. If you still need to do that, this is your one chance to prepare for the next types, because they're going to need you to be very comfortable with this kind of reasoning. What I'm going to do for the rest of today's class, I'm going to give you a choice. I wouldn't mind you doing this actually on whiteboards with a partner. But if you just want to sit there and just do it on paper, that's fine as well. But I'm going to give you the choice. If you want to just partner up with someone in the class, like, hey, let's do this together, because I need to bounce ideas off of you, then just take page 51 and just grab a whiteboard of your choice and just go for it. If you'd rather just do it on paper, go for that as well. Okay? So that's what we're doing for the last 15 before we move on to the next type, which is tomorrow. Okay? Thank you, guys.